Okay, so we're going to be solving solving systems of equations using matrices today. But in order to do that, we're just going to do a quick review of how to solve a simple equation. So let's go really slow. How would we solve this? Well, the easiest and fastest way is to multiply by 3/2 on both sides. Where did I get 3/2? Well, 3/2 is the multiplicative inverse of 2/3, giving me x equals 8 over 1 times 3 over 2, which is 12. So x is 12. And the process I used is I multiplied by the multiplied by the multiplicative inverse. All right, and both sides and simplified. It's pretty simple. Multiplicative inverse and the multiplicative identity. I could have gone slower and said, hey, that gives me 1, which is the multiplicative identity. I didn't. I just really used the multiplicative inverse. Used it very quickly. So that's very simple. We know how to solve that. We've been solving that one for years. The question is that we have systems of linear equations can be used with matrix equations. The PL is using the same properties that we did for our first equation. First, we need to recognize how a matrix equation can represent a system of linears. We can write the system as a matrix equation, matrix A times matrix X equals matrix B. So this is a matrix equation. Here's matrix A, X, and B. And what would we do to solve it? So what is the matrix I'm solving? So I'm just going to do some matrix multiplication here. 3x plus 5y. And when I do that multiplication, I'm going to get -1. So this times this. There's no other row, so it goes and then it ends up here. So that's pretty straightforward. We've done that a couple of dozen times now. So for the next equation, I'm going to do these, and I should get 4. So it's going to be 2x plus 4y equals 4. And so this matrix equation right here, I'm going to erase all my circles, can be represented as this system of equations lower down here. So, or the system of equations can be represented as this matrix equation. It's a pretty straightforward thing. Using the relationships, let's go ahead and write down this matrix equation. So what's going to happen? Well, the coefficients are going to be peeled off and become a matrix. And then 2 and 3 need to be times by x and y. So x and y like that. And since I'm multiplying a 2 by 2 matrix by a 2 by 1 matrix, I'm going to get a 2 by 1 matrix over here, which will be 14 and 20. I'm talking about this slowly, quickly, just to kind of get us familiar. So we pull the coefficients off. This is x and y, and this is that. So if we had a longer system that had 3 equations and 3 unknowns, we would be using this. So this idea. Are there any questions right now? Of course, you can't ask me them. So the rational numbers 2 and 3 are multiplicative inverses. What is the multiplicative inverse of this matrix? So we're going to take our matrix, we're going to find its multiplicative inverse. We're going to do that by finding the determinant, which is 8 minus 9, which is -1. And so I'm going to multiply by 1 over -1, this matrix, but I have to switch the places of 4 and 2, and 3 and 3 stay in the same places and change signs. So I'm going to do some scalar multiplication. I'm going to get -4, +3, 3, and -2. So everything has changed signs because of this number, and this is my inverse. So this is equal to that. Okay, so first I found my determinant. I multiplied by 1 over my determinant after switching the elements in my matrix around a little and got my inverse matrix. So we're going to use this to help us. So the following table is steps we could have used to solve this equation, which we've already solved, and we're going to try to solve the equation we wrote in number 4. I think really number 3, but so we're going to try to solve number 3. I should say number 3. Okay, so we have our matrix equation that we wrote. It is written wrong, so let's fix it. It should be 2, and that should be 3. Let's see, actually. This is wrong. 2, 3. Those are just in the wrong places. Okay. So the first thing we're going to do is multiply this by its inverse. Now we just found the inverse right here. So we're going to multiply -4, 3, 3, and -2. That's our inverse matrix by our current matrix. But if we do that on one side, we have to do it on the other. We're going to go as we have to put it in front, otherwise we will not be able to do the matrix multiplication. And I need some more paper. So I'm going to multiply -4, -4, 3, 3, -2 by 14 and 20. And really all the action is going to end up happening on this side of our equation. This side, we should get the identity. The product of inverses should give me the identity. Let's just make sure. We're going to get -8, -8 plus 9, which is 1. We're going to get -12 plus 12, which is 0. Not 6 and -6, which is 0. 9 and -8, which is 1. And so we did get the identity, which is great. Okay, you can see here that they haven't done this multiplication yet, so we won't do ours either. -4, 3, 3, -2 times 14 and 20. So we're going to go ahead and we know a number times its inverse is going to be the same thing. We're going to jump a step ahead. And we're going to go ahead and do this matrix multiplication very slowly. So -4 times 14 is 56. And 3 times 20 is +60. So my words aren't going to match up perfectly, but we're going to do our best. And then we're going to do 3 times 14, which is 42. And -2 times 20, which is -40. So we're going to write down our answer. We've got xy. And then this becomes 4 and 2. And so what does that mean? So we have this answer, and the next question, number 6, says, what does the last line in table 5 tell you about the system of equations in question number 3? So we've got our last line here, and that means that x equals 4 and y equals 2. Or in other words, the answer to my system of equations is 4, 2. And so we're able to use that information to make the answer to the system. It's a pretty straightforward, simple process. So next what we're going to do is question 7 asks us to use what we just did to try to answer this one. And I'm going to let you do it on your own after we write down the matrix equation. So we've got this system of equations here, which can be rewritten as 3 and 2 for the x's and 5 and 4 for the y's times xy, the xy matrix, equals two numbers on the other side of the equal sign, -1 and 4. The first thing you need to do is rewrite it. The second thing you need to do is find the inverse equation, the inverse of this. So next thing I'm going to do is find inverse of this. Then I'm going to multiply both sides by the inverse to get my answer. Good luck to you, and we will talk about the answer to this equation on Monday. The next time I see you. I don't know if that'll be Monday. The next time I see you. Thanks, and have a good day.